Hi everyone, good morning. I hope you're able to hear me. Okay, so whatever we have seen as part of Python, that is more enough for data engineering. Okay, so if you want, you can go through that. Even I have given the material. So if you're interested, you just have a look on it. But basically, whatever we have seen, that is more and more enough for data engineering. And we are not a Python developers. We're always going to be a data engineers. So for Databricks, whatever we require, that we need to know it. So at higher level, like variable declaration is required and for loop is required. How we can create a custom functions we required. And Lambda functions, I'm going to take you through as part of our RDD, how we are going to use the Lambda style of the functions. So today I'm going to start talking about Apache Spark. Okay. So Apache Spark, what is this first? Okay. And before going to start, we need to know about few things before Apache Spark. Before Apache Spark, we need to know few things. So previously, how people used to do the data processing. If you take any systems, let's say we have a Oracle systems or we have a databases in simple word, I can say. So all these databases used to store the data. Okay, they used to store the data. So problem is we are having a storage problem as well as a processing problem, right? So for processing, we used to have traditional ETL systems. So traditional ETL systems are going to help you to process the data, right? So this is for processing. Forget about processing at this point of time. I wanted to give some brief idea about how exactly people used to store the data in the databases in the olden days. And later we are going to say like how exactly the Hadoop came into picture, and on top of how Apache Spark came into picture, that we are going to see. Basically, if I wanted to store the data, we need to have a compute. Okay, so compute is required. Let's say I have some storage. I wanted to store the data, then you need to have a laptop or you need to have a disk, or simply I wanted to say you need a system. So this system will be used to store the data. The system will be used to store the data. Let's say this system capacity is 500 GB. You just imagine. Once this 500 GB is completed, then you cannot store the data inside the system. Then what you have to do? You have to increase. You have to increase the storage capacity. On the same mission, you're going to increase it. On the same mission, you're going to increase the capacity. Let's say I increased up to 1 TB. Now up to 1 TB you can store. And if 1 TB is completed, again you have to increase the compute. Again, you have to increase the size of the system. And this is about hard disk side. So disk size that I'm just talking. And other way is RAM also is required, right? RAM size, you just imagine instead I'm having a 16 GB. You just imagine. I need a 32 GB. Then definitely you have to increase it. You have to increase the compute. I mean the RAM also need to be increased. So for the same system, you're trying to increase the capacity. For same system, you're going to increase the capacity. So that is how, like when I say storage, you're going to have a database in this particular system. Just imagine, you may have a multiple databases. So the capacity, if the storage capacity is completed, then again you have to increase the storage capacity. Then only you can load the data into the system. So you're increasing a storage capacity or processing capacity to the same system again and again. So the process of adding a capacity to the same system again and again, that we can call it as a monolithic approach. Monolithic approach. So that is how people used to do it in the olden days. Is everyone clear? Any question?
Sir, vertical scaling is also same like that.
I'll come to that. I'll come to that. Okay, so if you add the capacity to the same system and again, that we can call it as a vertical scaling. You're adding to the same system. So that is what olden days, maybe if you're aware of it, when I was in plus two or somewhere, I heard about supercomputer, or China is creating one supercomputer, something like that. I heard about it, very popular. Okay, so that is known as a supercomputer. Even if it is a supercomputer, but still there is many limitations. You cannot like if I hire one person, if I feed to him more and more, he will get fat only, right? In the same way here also, that will not do better processing.
Utilization will not be better.
Exactly, exactly. So that is one of the problem here if you go for vertical scaling. Okay, so to provide the solution for this issue, this kind of approach was there for databases. Okay, so even like what I can say, uh, before Hadoop, we used to store the data in vertical. I mean to say, we used to add the compute to the vertical scaling. Let's say one problem is there here. Not only one problem, there are many problems are there. I'm just going to give some highlighted problems. Let's say, for example, I wanted to add 500 GB is completed. I wanted to add this hard disk. If I wanted to add this hard disk, first you need to down the system. You cannot directly go and attach it. You have to down it and then you have to attach it. So that means downtime is more. Downtime is going to be more here. And that is going to impact the business also, right? So that has to be handled very carefully. Okay, so companies will expect as less as possible a downtime in their process. Okay, so but definitely there will be downtime. And downtime is one problem, and you have to install all this hardware, right? You cannot directly go and keep it. So it takes some time, definitely. And these are all the monolithic approaches we are going to have it. So why we are having this problem is as the data is getting increased, then storage problem was appeared. The storage problem occurred. Okay, so why this storage problem is occurred is because of the big data. Because of the big data, we got all these problems. Otherwise, there was no problem. So how can you say that it's a big data? Let
Because
me
the
write.
volume of the data is
Yeah,
becoming much more.
I will come to that. Okay, so basically to increase the compute, I'm just giving some note here to increase compute. We have two different approaches. One is monolithic approach and second is distributed approach. So why distributed approach will come, we'll talk about it. And I just wanted to say how a big data, or how can we say that is a big data, the characteristics of the big data. So most of you already we came across it. I'm just keeping everyone in mute. So the characteristics of big data, most of us are aware of it. If I'm correct, somewhere we discussed also. So three characteristics we're going to have. One is volume. Based on the volume, we can say it is a big data. Or based on the variety of the data, we can say that is a big data. And third is velocity. If you have any of this characteristic, then we can say it is a big data. Okay, any of them or all together may have in the big data. To say the big data, we can have at least one. Okay, so if you have a huge volume of data, it doesn't mean that only huge volume of the data is a big data. But even if you have a varieties of the data, I have a structured data and I have a semi-structured data, and I have a unstructured data also. So if you have these varieties of the data, then definitely you cannot do the processing, the systems which are supporting for monolithic approach. Okay, so monolithic approach means we have a database. So in database, you can store only structured data, not a semi-structured data and not a unstructured data. Okay, so that means your system is not capable enough to process the system because I have a varieties of the data. So if I have a varieties of the data, then I can say my data is a big data, even if I have a less volume of data. Volume, it doesn't mean it's going to be only big data. So the varieties also is going to be treat your big data. I have a less volume, but varieties of the data is there. Then I can treat that is a big data.
Sir,
Okay.
but in the database, I think we can store the semi-structured data, for example, JSON.
That
Yes.
came into later. Okay, so before Hadoop, there was no such kind of things. Okay, so this Cosmos DB or Cassandra, all this came after Hadoop. Okay, so I'm just talking how this big data was evolved. Okay, so the next is velocity I'm having. Velocity means a speed by which data is received. So the speed of receiving the data, how speed we're receiving the data. So if there is a huge speed in the data, then definitely that is going to be big data. The data is getting generated faster. You're receiving the data faster. Okay, so that is a velocity. Or if like if you take a sensors, or there are many are there. Even if you take a what we can say stack exchange, or I'm not exactly so, yeah, stock exchange if I'm correct. Okay, so they used to generate the data very frequently, and there are some websites also. Okay, if you take a Facebook, the data will get generated very fast, right? And if you take a WhatsApp, the data is going to be generated very fast. So that we can also is a big data. So these three V's are going to represent, the three V's are going to say, is that a big data or not? If any one of them is getting satisfied, then we can say it is a big data. As simple as that. Okay, so volume, we already know it. It's a huge volume of the data. Okay. So if you have a olden days, as I said, we used to store the data in the RDBMS systems, right? So only in the RDBMS systems we used to store. And if the storage is filled, then we are going to attach the compute to the same system, not other systems. So that is what it is, a monolithic approach. So monolithic approach will not improve the performance. As the data getting increased, as the speed of the data is getting increased, as the varieties of the data was introduced to the market, then these particular systems are not capable enough to handle it. So because of that reason, we got a distributed system. So how distributed system is going to work? So let me take an example so that you can have an idea. Let's say, for example, if you remember, we came across how we can do, or how we can load the data for multiple tables as part of data factory. But just ignore for time being. I just wanted to say I have a 10 tables to load the data. I have a 10 tables to load the data. If I wanted to load the data, 10 tables, in olden days, how people used to do it in a RDBMS is, I'm just taking an example, Oracle. Okay. So they used to write a insert statement, right? If I wanted to load the data into 10 tables, then I need to write insert statement. So this insert statement need to apply for 10 tables. This insert statement should execute for 10 tables. To execute for 10 tables, are we going to write insert statements for all 10 tables, or are we going to write only one insert statement and iterating the loop? So in olden days, they used to write like a looping. let's say I just wanted to write a loop, and this insert statement is going to be executed for 10 times. So how many persons are going to do here? Only one person. Only one system is going to do it. Only one system, it will take first table, then it insert the data, then it will take second table, then insert the data, third table, insert the data, something like this. It is going to be happen in the olden systems. Now, if I take the same example for distributed system, how it is going to work is, so I'm going to create a 10 different blocks, or let's say 10 persons. I'm going to take a 10 persons. So 10 persons means like 10 systems, you just imagine. So this person is working for one table, second table, third table, and so on. Okay, so to load the data into this table, if it is taking 30 minutes here, just imagine if I have a 10 persons to load the data into the 10 tables, how much time it will take? Every person is going to take 3 minutes. So the total time is going to be 3 minutes only. Is that correct or not? If one person is doing your work to load the data into single table, 10 tables, then 30 minutes is taking, because for every table it is taking on an average, I'm just saying 3 minutes. But if the same work is done by multiple persons, then the time is reduced. Is processing faster or not? Okay, so it is faster. So this is one example I can say. Let me take one more example so that we can get little more clarity related to big data. I just wanted to give. Let's say I have a 10 GB data. I have a 10 GB data. If I wanted to load this 10 GB data into single table, my target is single table. I wanted to load the data into single table. Then what happens when you give it to the distributed system, or let's say, for example, forget about even distributed system for time being. I wanted to break this data into multiple pieces. I wanted to break this data into multiple pieces. Okay, so like let's say I wanted to say multiple pieces like 1 GB, 2, 3. Each and every item is going to be 1 GB. Okay, so 4, 5, 6, 7, 8, 9, 10. Okay, so this one I wanted to call it as a block. Okay, so a block, or I wanted to say it is a partition. I wanted to block. Okay, so 10 partitions I wanted to create it. 1, 1, 1, 1 GB. Okay, so let's say 1, 1, 1. Okay, so all are going to be 1 GB only. Like that, I have a 10 blocks. So 10 blocks are required, and every block I can also treat as a partition. Okay, so partition or block at this point of time, same. Of course, both are same. So when I say block, it comes under the storage. When I say partition, at the time of processing, we are going to call that as a partition. Of course, there will be no much difference, more or less same. Okay, so if you have a 10 blocks, to process this one partition or one block, if it is taking 3 minutes, here 3 minutes, here 3 minutes, like this, it is going to do 3 minutes. So since this are all going for parallel processing, the total time is going to taken here is 3 minutes. You're not doing with a single system. Your processing is going to be done by multiple systems. So this is what it is, a distributed approach. You're distributing your work items to the multiple persons. So when I say multiple persons, means it is just systems. You're going to have a distributed system is something like this. This is system 1, machine 1, machine 2, machine 3, something like this. So all these three missions are going to be connected together. How they're going to work together for timing, you just ignore it. So I wanted to say it is a distributed system. Okay, I wanted to say it is a distributed system. Okay, so multiple systems are going to process. Multiple systems are going to process. If you process this 10 GB data with multiple systems, then it is going to take 3 minutes. And if you give it to single mission to process or to store, it's going to take longer time. And if you go with monolithic approach and store this 10 GB data, in the olden days, what happens is, if at all, if this system is, for some reason, if it is crashed, then you are going to lose the data because we don't have a feasibility. You need to, like, if you have a supercomputer, you need to have, if it is a, I mean to say, one primary supercomputer, and the same thing, we need to have a one more supercomputer to keep the backup. Okay, so we need to have a one more secondary system. If at all, if this is done, then we can make it up to lose, to avoid losing the data. To make it highly available, then we need to have a one more system. So that is very expensive. Okay, so that is also is one of the problem. Okay, so fault tolerance is a problem. Scalability is a problem when you go for monolithic approach. And if this is not working, this has to come up. Just imagine, like, to bring this up, it is going to take some time, definitely. And you need to write the data synchronously between between these two systems. Okay, but when it comes to the distributed approach, what happens is, if this mission is not working, if this mission is not working, still I can access my data. I can access my data because the data is not going to store in one mission. The data is going to be distributed. Data is not there in a single place. Okay, so all the data is going to be available in these two systems also. I'm just taking an example, three systems here. Okay, so if any one of the machine is not working, still I can access my data. Still I can do process. But when it comes to here, if it is down, then you cannot access the data. So something has to be get up. So you cannot have a same systems we cannot have a same multiple systems. But when it comes to here, the cost of this system is less because this system is a supercomputer. This system is like a commercial, or what we can say, um, it's an economical system or commodity systems. Everyone can buy it. It's normal systems like the way we are going to use in in our
Virtual machines.
houses, not virtual machines. Forget about virtual machines. Okay, so for time being, I'm just saying physical machines only. Okay, like like we have a desktops, right? Desktop systems. Previously, even now people are using laptops. Very huge usage is there. But if you take 15 years back, then basically people used to go for desktop systems. So those kind of systems we can use for cluster, or we can use it for distributed systems. So the price of that system is less. Like if you have a 8 GB RAM systems, let's say this is the 8 GB and this is 8 GB and this is 8 GB, the cost of the system is less. But when you go for same 24 GB system here, the cost will be different, more. Okay, so we can afford, and we can have a more a processor, and size storage also is going to be more when compared with this. Okay, so we can avoid many issues. If you go with the monolithic approach, the first problem is scalability. The very first problem is the scalability is one of the problem. So if you wanted to increase the compute in the form of storage and processing, RAM, everything, you have to make it down. Then you can go for increasing the compute. Okay, but when you go for distributed file system, we can, even if any one of if system is required, like Mason 1, Mason 2, Mason 3. These are all connected, right? If I wanted to add a new Mason to this existed system, I can add it. I don't need to make it down. I can bring it and keep it in the cluster. Okay, so that feasibility we are going to have when you compare monolithic approach and distributed approach. So scalability is one problem. Another problem is fault tolerance. So that means if the system is failed in the monolithic approach, there is no option, there will be downtime. But when it comes to here, if any one of them is down, still you can access your activities. So that means it is highly available. Okay, so distributed approach is going to have a highly available here.
Sir, this
And
fault tolerance, is it linking to the reliability?
of course, it is going to link. The cost is more cost monolithic systems, supercomputers. And when you go for a distributed approach, the cost of system is very less. So because of that reason, this kind of approach was introduced to store the data. Okay, to store the data, basically, uh, Google, uh, I think, map produce. I'm not exactly sure about all those terminologies. Basically, the Google released a paper in the year of 2004, um, like distributed platform. Distributed platform or distributed approach. Okay, so that is going to, like, your monolithic problems are going to be solved as part of with distributed approach. So in distributed approach, we can share the data across the systems. We can process the data across the systems. Okay, so in order to store the data, they introduced HDFS, Hadoop Distributed File System. Okay, so later many things are happened. I'm not taking all of them to like how exactly it was evolved. I'm not taking into that because we are not going to be part of that particular all those things. Just for understanding, I'm saying it.
Sir,
So
1 second, please.
yeah,
I think the distributed format from Google was GFS, GDFS, Google Distributed File System, and when this Hive came into
yeah,
picture,
yeah,
they made it HDFS.
exactly. Later it came, but initially it was started by Google only. Google or Yahoo. Yahoo also was there, if I'm correct. Yahoo also is part of that, and there were many ecosystems also came once the Hadoop was introduced. Okay, so I mean to say, like Pig is there, HBase is there, Hive is there, because that Hadoop was introduced. That means MapReduce basically used to do it with Java programming. So writing Java is a little difficult for people, many people. So as it is a open source, on top of it, other flavors also comes into the picture. We used to call them as like a Hadoop ecosystem. Okay, so like when you have a HDFS, that is also is a distributed file system. Okay, DFS just that is the initial days that we had it. But when it come to the Hadoop, HDFS, Hadoop distributed file system, we have a cluster. Okay, so we can distribute the data to store. The data is not going to sit in a one Mason. This is Mason 1, Mason 2, Mason 3, and Mason 4. Okay, so this is Mason 5. Just imagine. If I have a data here, employee dot CSV, when I store the data into HDFS, the data is going to distribute across the different nodes because this file will be divided into blocks. The file will be divided into blocks. Okay, so since I'm going to talk with Apache Spark, based on the Apache Spark, I'm just taking the size of the block. The default size of the block in Spark is 128 MB. And if you want to increase, still you can increase. If you want to decrease, you can decrease it. It's all depends on your requirement. But by default, 120 MB is the default block size in the Apache Spark. Okay, so based on that only, I'm just taking this one. And they took this 128 MB based on many use cases or testing in different approaches. They finally fixed with the 128 MB. Just imagine if you have a data here, this file will be divided into multiple blocks, and blocks will be distributed across the different nodes. The same thing that we discussed in the ADLS also. How ADLS is going to distribute the data is because they're also using the same DBFS. Okay, so distributed file system, DFS. Okay, so on top of it, everyone built this kind of storage systems. Like if you go with S3, they also follows the same thing. ADLS also follows the same thing. Okay, so they have their own mechanism, but all are distributed platforms or distributed file systems. Okay, so now the question is like when you have a cluster, how these systems are going to work together? Okay, so that is one question here. If I have a cluster, how all these three together is going to work? All these three together is going to work. Let's say, for example, take an example. Most of us, we already come across this Python, right? Or maybe if you're aware of Java or anything. When you write some statements, if you wanted to execute it, without operating system, can we execute it? Or without OS, can we use a system? We cannot use it. So that means this code is going to be converted to make it understandable, like machine understandable language, like binary code or something. It is going to do it, right? In the same way here, operating system is required to coordinate with the Python or coordinate with some language or anything. If you wanted to use anything in the system, we require operating system. In the same way, in order to, because this like if we have a single, then that is also system. And here when you connect all these systems together, it's a big system. In simple way, I'm saying. Okay, we don't say it is a big system. We used to say it is a cluster. Basically, this is a cluster. Cluster is nothing but collection of systems. Okay, so how this big system is going to work together? So some operating system is required. That some operating system is known as resource manager. We have many resource managers are there in the market. Most popular is Yarn, yet another resource negotiator. Okay, so when it comes to us, we are going to use Spark standalone, resource manager we are going to use. But basically, we have a Yarn also. We can use this Spark itself is having their own resource manager, and we have a Kubernetes. There are many other. Okay, so many resource managers are there. So this resource manager is going to handle this. His resource manager is going to make them to work together. Okay, so in other words, I'll take a generic example. Okay, so do not feel this is completely theory, but you need to understand this concept. So most of the people are going to have a lot of confusions in this particular place. Let's say, for example, we're all developers, right? Let's take your team or my team. Okay, so I have a manager. Okay, I have a manager, and I'm a developer. So let's say developer 1, developer 2, developer 3. I'm just taking 4 developers here. Just imagine. For all these 4 developers, we required manager. Okay, we required manager. Now this manager is not a technical person. Okay, so generally if we take any company, you will be having technical manager or non-technical manager also. Okay, so in my previous company, my manager is a technical manager. In my current company is non-technical manager. So just imagine there is a non-technical manager. He handles the resources. He handles the resources. He cannot do the development. Okay, so to work all together, developer one, developer two, developer three, and so on. So this manager is going to be responsible, right? So manager is going to coordinate them. Okay, so that means what I can say. Basically, this manager is a non-technical manager, but he is not aware of how technically people are going to work, right? He manages the resources, but he doesn't know about how to work or what is happening exactly. So he can do or he can monitor only functional level only. So what he will do is, in general, one of the developer is going to work as a technical lead. Okay, let's say for example, I'm taking developer two. I'm just taking this developer two as a technical lead. So non-technical manager is required technical lead. Okay, so without technical lead, you cannot like the project cannot be moved forward, right? Okay, so if you want to make them work together, manager is required. But to monitor or to distribute the work, one of the person from the development team is going to work as a technical lead. Okay, so he's going to be perfect in a technically, and he's going to distribute the work across the developers. But for all these people are going to be managed by manager. So that manager is Yarn or Spark standalone. Okay, so Kubernetes is there. There are many are there. Okay, so many resource managers are there because a company can recruit multiple managers, right? So in that way, I'm just saying it. So manager is nothing but your resource manager to manage to manage the resources. Okay, so this technical lead is there, right? This technical lead, what he is doing, he is going to lead the team. Is going to lead the team. But if we need one more person to, I mean to say, if the project requires one more person, technical lead cannot recruit the person, right? So he has to ask the manager to add one more person. So this person will be decided like how much time we require to deliver the product, how like 6 months or 1 year. This kind of discussions will be happen. So to recruit the person, then manager is responsible, and to distribute the work across the different team members, then a technical lead is required. So that means this technical lead is going to drive your work items. So this technical lead, we can also call it as a driver node. Keep in mind, it is very important. So when you go for Hadoop architecture, there is a fixed node that is a master node. Okay, so master node is going to work as a driver node. But when it comes to the Spark, any one of us is going to work as a driver. We cannot give a guarantee. But when you go for Hadoop architecture, there will be fixed master node. Here we are not going to fix it. That is the beauty of Spark. So any one of us is going to work as a driver. Now let's say, for example, if manager is not available, if manager left the company, then can we handle the project? I mean to say, not project in general. Let's say you submitted some application, some job to run it. Okay, so while it is running, the manager is failed. Okay, for some reason, the manager is failed. Or in other words, because manager is not going to work, right? So let's take this driver node, because driver node only is going to distribute the work. So if at all, if this driver node is failed, then your job will be failed, because driver only is going to decide. Okay, so the distribution of the work is going to be decided by the driver. Okay, so if at all, if driver is failed for some reasons, then your job is going to be failed. So in order to provide the solution for that kind of situation, you have to relaunch the job. Then these three persons are there, right? So one of them is going to work as a driver. So here, if one is failed for some reason at the time of execution, then the job will be failed and you need to relaunch the job. Okay, you need to relaunch the job to work it again. So driver should not be failed. Now another example I'm taking here. If developer 4 is down or he left the company, can we process this job? You just submitted the job. For some reason it was down. Then this 3 persons only is available. Can we process this data?
Sir, we can.
Yes, we can process it. Okay, so if driver is down, then there is a problem. If worker, this is a worker only. This person is a worker. Okay, so worker is down, then there is no problem. Still you can go. But if you do the same thing with monolithic approach, what happens? If it is failed, it failed. Okay, so that many features are available when you go for the distributed approach. Okay. So Hadoop was introduced with the distributed approach only. So because of that reason, that time the Hadoop, like anything a decade ago, the Hadoop like anything in the market. It was a hot cake. But still there are many limitations are there in the Hadoop. There are limitations are there in the Hadoop. Okay, so I'm just going to list down some limitations, because our journey is not to talk about Hadoop. Okay, we don't need to know about the Hadoop. I'm just saying how the data processing evolved from right from the OLTP system till the Spark. Okay, so limitations of Hadoop I'm just giving. The first one is, like, if you have a smaller size files, then there is a problem. Issue with small size files. And it is going to have a slow data processing. And we're going to have a latency. Why it is a latency? Why it is going to slow down? We're going to talk about it. I'll give some brief idea about it. And security. And it will not support for streaming data processing. So I can say it is a no real-time data processing, which means it supports only batch processing. Batch processing only supported. So no cache, because data will not cannot store in the cache. Not easy of use. Okay, so these are all some limitations I'm just giving. Out of all this, I'll pick few things and I'll explain. Okay, so I just wanted to concentrate on this slow data processing or latency. These two are more or less same thing we are going to have. So why the latency means it is slowness. It is going to be slow to process the data. So why it is slow is, let's say for example, I have a data employee.csv, and this data you kept inside the HDFS. Okay, so this data is there in the HDFS. And in order to process this data, for storage, we are having a HDFS when you go for Hadoop. And for processing, we are going to have a, Hadoop is going to have a HDFS as well as MapReduce. We have a HDFS and we have a MapReduce. So this MapReduce will be used to process the data. I have a, let's say I have a task one. Just imagine this task one is created with the help of MapReduce approach or MapReduce program. So this task one need to read the data from the HDFS. Task one need to read the data from the HDFS. So reading is required. And it does some task and the output we need to store, right? That output is going to store in the again in HDFS. Okay, so this is a source. And I have one more task, task two. So this task two again is going to read the data from the HDFS. This HDFS is an intermediate storage. It's an intermediate storage. And task two is going to read the data again. So that means again you're reading it. Here you're writing. You're writing here and you're reading here. Okay, so finally you just imagine I have a target. The final target. The final target is also HDFS only. Again you're writing here. So that means what you observe here, multiple times readings and multiple times writing. Okay, so it is always going to deal with the disk only. So data is loading and writing, loading and writing. So that is going to slow your processing. So that is one of the limitation, major limitation in the Hadoop. Okay, so that is one of the major limitation. Another is it is going to support only batch processing. You cannot go for real-time data. If I wanted to process streaming data, then I cannot do the streaming data processing with the help of Hadoop. Okay, so you need to go with other platforms to process the streaming data. But when it comes to here Spark, the Spark itself is going to have it. Still, I did not touch the Spark. So I'm just talking about a Spark, how exactly it was used to do the processing. Okay, so these are all limitations we can say. And one more important thing that I wanted to take is not easy of use. So in order to write this MapReduce, you have to use the Java. You have to write the Java. So later, initial days of Hadoop, only there was only Java. If I wanted to process the data, you have to write a Java code only. But later, some ecosystems were introduced like Hive, HBase, Pig. Okay, so to simplify this on top of it, because this MapReduce is pure Java, so on top of we are having a ecosystems. So those ecosystems are little easy, but you have to depend on the ecosystems to provide the solution. That is one problem. Another problem is what I can say. So you have to go with only Java only. Finally, if you wanted to write a coding, you have to go with the Java. If you want to communicate with the database, then you can go with the Hive to write a SQL style of the coding. But it's not that easy to use it. Okay, so and no cache, you cannot keep the data in the RAM. It has to store the data in the HDFS. Once the task is completed, it has to write the data into the HDFS. You cannot hold the data in the RAM. Okay, so that is also is one of the major limitation in the Hadoop. Okay, so I'm just saying few of them, and you need to write too many lines of the code when you go for Hadoop. Okay, so keep in mind all these limitations. Why we are getting this Apache Spark, you can understand. So Apache Spark is going to provide the solution for all these issues. It is proven. Okay, all these issues are going to be solved by your Apache Spark. So Apache Spark can handle the small files, okay, with higher performance, because we can, you can read it, but you can, what you can say, you can you can reduce the number of partitions. If you required, you can decrease the number of partitions. If required, you can increase the number of partitions. Okay, so many things are there that I'm going to talk about more in detail about the Apache Spark in the next session. So today's session is important theoretically, because many people are going to have some doubts. They may not have a clear picture on why Apache Spark, or later Apache Spark, why Azure Databricks or Databricks. So that we are going to see mostly on the next session. We are going to start talking about Apache Spark. Theoretical concepts are going to be there for next 2 days, but they are very important for interview point of view. Okay, so they will ask what is a driver node, or when you submit application, how that is going to be processed. So that I'm going to talk about it on tomorrow's session. Okay, I mean to say not tomorrow. I think you people asked this weekend, leave for this weekend, so that you can just go and complete your practice, whatever you have done. On Monday, I'm going to start talking about Apache Spark. Is that fine?
Yes, sir. Sir, I have a question. Can I go ahead?
Yeah, please.
Sir, while discussing about the nodes, we had a master node and other worker nodes. Out of the worker node, one will be represented as a driver node.
No master node here. Basically, when you go for Hadoop, there is a master node. When you
Okay.
come to the Spark, no master node, driver node.
Okay. So, driver node and what
Worker
about
node, worker nodes.
Okay.
Okay, so you will get little more clarity on Monday session, because I'm going to talk extensively with the Apache Spark.
Okay, sir. Driver node and out of driver node and worker node, you mentioned when the driver node will go down. So in that case, what will happen?
You have to resubmit the application. You have to rerun the job.
Okay.
When you rerun it, so 3 persons are available, right? If one driver is down, okay, so this one of this person is going to work as a lead.
Yes.
If lead is on leave, one of the person can lead the work, right?
Yes.
So that is how it is. So here, no specific node is for a lead. Any node can work as a driver. That will be decided by your resource manager. Okay, so you will be having still little confusion. So on Monday, you're going to get little clarity.
Okay. Yeah, yeah. Frankly
Because
speaking, I'm having doubts.
Even I do have very starting of Apache Spark. I always used to compare with the Hadoop. That was a problem.
Yeah, this hierarchy is not clear to me yet. Okay, I'll
Okay,
try
so
to go with some.
you will get it. You will get extensively. We are going to talk with the Apache Spark standard naming standards. Okay, so in Hadoop, we have a master node and worker node. Master is fixed.
Yes.
Like in our company, team lead will be the right. Team lead will be fixed. But when it comes to the Apache Spark, lead is not fixed. Anyone can work as a lead.
But the resource manager is a
Resource manager doesn't know about technically, right?
yes.
So on Monday, you will get little more clarity. Who will get the work? Who will distribute the work?
Okay. Yeah. Meantime, if possible, I will also go through some videos.
Yeah.
Okay, to understand. Yeah.
Okay, then we'll see on Monday. Thank you.
Thank you, sir.